All right, chapter 4 test. I want to go through, do the solutions here, and then that way if you need to do a retake, hopefully I can explain how to do these a little bit better. So number 1, graph the systems of equations below to find the solution. Express it as an ordered pair. You may need to use a graphing calculator and round to the nearest tenth. So if you're doing it by graphing, you graph this thing and you're like, well, first one, this is the y-intercept, this is the slope. So y-intercept of -4, slope up 4 over 1, up 4 over 1, 4 over 1, and go down. Come all the way through there. And you need to use a ruler to do it, to be really precise and close, because we want to know where these two are going to cross. And then the next one, I solve this thing for y. So it looks like if I just divide both sides by 2. So I'm going to divide by 2, divide by 2, divide by 2. And I get -3 plus 1/2 x equals y. So it's just on the left side instead of the right side, but no big deal. So we cross at -3, and the slope is up 1 over 2. Up 1 over 2, up 1 over 2. So when you graph this, you'll notice that, I kind of missed my point, but we notice that it's crossing somewhere in here, but it's in a weird spot. All right, so what I might do is I might use my graphing calculator, and I'm just going to kind of zoom in, somewhere in that area. So I might want to maybe make my x's go from, I don't know, -3 over to +3. And then maybe I'll make my y's go from I don't know, -5 to 0. Maybe something like that. And that way I can kind of zoom in on this window right here. And my calculator will zoom right in on that area, and we can see what's going on. So let's put these two lines in. You do need to do this part before you can enter it in the graphing calculator. So let me bring up TI here, and I will slide it over. Kind of put it out of our way so we can still see it. So I'm going to go to the y equals menu. I'm going to clear out everything that's in there. I'm going to go to my window because I don't really want to do this whole square. I'm going to kind of think we're going to focus on -3 to 3. And I could go by 1 still. I can count by 1s or 0.5s, whatever I want. I think the y min, we're going to go from -5 to 0. And you could, if you wanted to, just graph it and then zoom, but I kind of like controlling my own window. All right, so here we go. The first one, I'm going to bring these back up. So we had y equals 1/2 x minus 3. So 1/2 x minus 3. So I'm going to do parentheses. 1 divided by 2 x. So there's 1/2 x minus 3. Enter. Then the other one was already in the right form for me. It was just 4x minus 4. 4x subtract 4. Enter. And let's graph it. And I can see that one crosses at -3. That one crosses at -4. And it's going to be at a weird spot. So I'm going to now make the calculator find that intersection. So I'm going to go second, trace, which is the calculate menu. Go down to intersection, hit enter. Now, first it has the x on this line, so I'm going to hit enter. Then it should jump over to the other line. Enter. And let's guess the intersection. And right there it tells it to me. It says it's x equals 0.28. So the x is 0.28 and a bunch of other numbers. 0.29, I guess, if we were rounding. And then -2.85, blah, 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 blah. But we said to go to the nearest tenth. So that's basically at 0.3 and -2.9 would be the crossing points. So that's how you find the intersection when it's in a weird spot and you have to graph it. Now, you also could have used algebra if you wanted to. I'm not going to go through all that. But you could have used algebra if you wanted to solve it exactly that way as well. But I asked you to graph it. Next one, number 2, Lynn is flying a plane. I'm going to set this one up using algebra because I think it's a little faster than the table. So Lynn is flying a plane at altitude 10,000 feet. She begins to descend. That means go down. So descend means I'm going down. 200 feet per minute. 200 feet per minute. That's going to be really important. Then we got Miguel. He's flying a different plane. He starts at 5,000 feet, but he is climbing. So he starts at 5,000, but he's climbing 50 feet per minute. And I want to know, when will they be at the same altitude? So when are those two equations going to be the same? So I'm going to kind of set it up like this. I want to know, when is Lynn going to be equal to Miguel? Well, Lynn starts at 10,000, and then she is decreasing or descending at 200 feet per minute. So I'm going to define my variable. I'm going to let m equal minutes. You could use x if you want to, but m makes a little more sense for me. Now Miguel, he starts at 5,000 feet, but then he is increasing. He's climbing 50 feet per minute. So now we should be able to just use some algebra. If I add 200 m's to both sides, I'm going to have 250 m's. Well, I know I want my numbers on the other side, so I'm just going to on the same equation, subtract the 5,000. So I get that. Divide both sides by 250. And we get an m equals 20. So our minutes was 20. So after 20 minutes, that's where they're going to be at the same. Now, what altitude will it be? Well, that's where I'm going to take this m equals 20, and I'm going to plug it into either equation, whatever one I want, and I'll find out the height. Should be the same in both of them. But 10,000 minus 200 times 20, well, that's 10,000 minus 4,000. So it looks like after 20 minutes, we are at 6,000 feet. And you get the same thing if you put the 20 in over here. You'd have 5,000 plus 1,000, which would also be 6,000 feet. All right, moving on up to number 3, solve the system using any method of your choice. The way it's set up, I would like to eliminate. Can't really eliminate just yet though because I don't have any opposites. So I think I'm going to multiply this row by 2, and that way I'm going to eliminate x's. So top row I don't mess with. Bottom row I'll have negative 2x, positive 2y, negative 8. Add those two rows together. You're going to go away. I'm going to get negative 2y equals 10. Divide, divide. And I get y equals negative 5. Now we just got to go back and we just got to plug it in. So maybe I do the top equation. 2x minus 4 times, but instead of y, substitute what it is. And that's 2x plus 20 equals 18. Be careful here. Minus 20 from both sides. Negative 2, divide, divide. And I get x equals negative 1. You could also express that answer as an ordered pair. This is where they would cross if I were to graph those two. That would be the intersection point. All right, moving on down. Number 4. If xy is the solution to the system, what is the value of x plus y? So on this one, we actually got to find x, we got to find y, and then our final answer, we're going to combine those two and put them in there. So looking at these, I don't see any way to get opposites by multiplying the 4, and I don't see any way of multiplying the 7. So unfortunately, I'm going to have to multiply both rows. all depends on what we want to eliminate. If I multiply this row by 9 and this row by 4, I'll get 36s in the front. I should make one of those negative. And I'm going to choose the bottom because there's more negatives down there, and I kind of want to cancel them out. So what I'm going to get, when I top row, I'm going to have 36x added to 63y. Remember, I'm just distributing kind of. I'm just multiplying across. And that's 180 and 54, which would be negative 234. Bottom row, I get my opposite, sweet, negative 36x plus 32y equals, that'd be 44. Combine, you're gone, you gone. 95y equals, that's a negative 190 when I add the two rows. Divide, and I get y equals negative 2. Now be careful, if this was an SAT test, for sure, part A, answer A, they would have negative 2. They're trying to get you. We need to know what x plus y is. So we know the negative 2 part. Now we got to go back and we got to get x. So I'm going to substitute. I'm going to go back up to my original equation. And I'm going to substitute negative 2 in for y somewhere. Maybe I'll do the top. So 4x plus 7 times the negative 2. Well, that's a negative 14. Add 14, add 14. And divide. And I get x equals negative 3. Now, they will probably have one of the choices as negative 3 because they want to trick those people. But we know better. We know that negative 3 plus negative 2, the correct answer is negative 5. So that's the final answer to the question. Number 5, another system. This one's kind of a freak case, I like to call it. I want to get somebody to match, so I'm going to get my opposites here by multiplying by a negative 3. So top row I'm going to leave alone. Bottom row, multiply everybody by negative 3. And you will notice something very weird happens. When you combine the rows, x's and y's all disappear and I get 0. Now, when this happens, one of two things are going to happen. We're either going to have an infinite solution or we're going to have no solution. How you know which one it is depending on what happens on the right-hand side. Well, when I add these two together, I get 1. So, this is not infinite solutions. Infinite solutions, you would get 0 equals 0. That didn't happen here. When you have a false statement, like we have 0 equals 1, this is a no solution problem. 0, 0, infinite. No solution is 0 equals some other number. Doesn't really matter. So anytime you get 0 equals some number not 0, you know how to choose it. Number 6, graph the system of inequalities and shade the solution. So, you got to keep track of some things here. First of all, they are both in standard form. So I'm going to convert them to slope-intercept form. So, I don't know, this one I'll go over here. So I'm going to leave the y where it's at. And I'm going to move the 2x to the other side so it changes sign. And I think I'm ready to graph that one. So I cross at negative 3. I have a slope of negative 2, which means go down 2, right 1. And I'm going to back it up and go the other way. And since this sign does not have an equal to bar, I know that it's dotted. So I know this is going to be a dotted line like that. Now I need to shade this line, and since it's y greater than, I'm shading above the line. I'm shading up here. So I'm going all this way. You don't really need to do all these, but I'm doing it for effect. Well, now I got to do the other one. So we'll do the other guy in blue. We'll do this one over here. Well, first thing I'm going to do is I'm going to move the 4x to the right-hand side. So I get negative y greater than or equal to negative 4x minus 3. Well, I can't have negative y. I need positive y. So I'm going to multiply or divide, whatever you want, everybody by a negative 1. So if I divide every person by a negative 1, that gives me y. I got to remember I need to flip the sign here. That was a big mistake a lot of people made. Always flip the sign when you multiply or divide by a negative. So now I have this line. So that line crosses at 3, has a slope of 4, and you might panic and be like, oh my God, I'm going to fly off the graph. No big deal. You know, if you want to, you could simply extend the axis up, guesstimate about where it is, and go back and start moving up and to the right, up 4 over 1. But you really could just go down the other direction. If you're going up 4 right 1, go down 4 left 1, down 4 left 1. And now I have a line. It does have the equal to bar, so it's going to be a solid line. So this line is going to be solid, not dotted. And now I got to get my shade right. It's less than, so that means I'm going to shade below. So that means I'm going to be coming down this area. And so the overlap region that got double shaded would basically be all of this stuff right there. Maybe that side of the x would be all the ordered pairs that make that whole system, both equations or inequalities, true. Number 7, use the information below. City of Milan's trying to plant maple and spruce trees, downtown park. So I'm going to kind of organize this stuff, and then I'm going to move because we need to graph it up top. So I'll show you how I organize this. So first thing, I'm like, what are we talking about? We're talking about spruce trees, and then we're talking about maple trees. So those are our two things we're talking about. So I'm going to come in and I'm going to define my variables. And I'm going to say, hey, x equals the number of spruce trees, and y equals the number of maple trees. All right? So there's kind of my two people, and it might be easier just to kind of put an S and an M here if I want. And let's see what we're talking about. Well, we're trying to absorb carbon dioxide. So first of all, I see some money. We have an $1,800 budget to spend on the trees. And then we have some maximum land. So let's kind of keep those in our back pocket. Well, spruce trees cost $30. So I'm going to make a table to try to kind of organize this data a little bit. So first of all, we have a cost. And spruce trees cost $30. And then they require 90 feet of space. So we also have the square feet that they cover. So the spruce tree was 90 square feet. And then the maple trees cost $40. And they cover, what is it, 90? No, they cover 60 square feet. And then I kind of come into these constraints, or my money has got to be $1,800 or less. So this top one is kind of like my money line. And the bottom one, my square footage budget, is 4,500. I got to keep it under 4,500. So basically what you can do is your equations are right here. Like you can make it right from the table. I have a cost equation. $30 times every spruce tree, whether I want to use S or X, it's fine, added to $40 times every Y tree, or the maples. It's got to be less than or equal to if I want to stay under budget. So there's one of my constraint equations. Now my other constraint equation is the square footage. which is basically 90x plus 60y, has got to be less than or equal to 4,500. So I've used every number over there, and I kind of have a nice setup of my constraints, what I have to stay within. So let's go up to the top, and let's fill this in. And I'm going to put them on the graph too. So here we go. So the first one was 30x plus 40y less than or equal to 1,800. And then my second equation was 90x plus 60y is less than or equal to 4,500. Now, I want to graph these on the grid. So what I'm going to do, because these numbers are bigger, I could solve in slope-intercept form, but I think I'm just going to do a little table. So I'm going to come over here, and I'm going to just use my intercepts. And I picked nice numbers for you. So when you let x equal 0, and you can't really see me, but if I cover my hand up over the 30x, I just have to solve 40y equals 1,800. Which means I'm going to divide both sides by 40. And I'm going to get 45. So that gives me an ordered pair, 0, 45. Well, then I have to do, if I cover y up and I let y equal 0, I'm going to get 30x equals 1,800, divide, and I get x equals 60. So 60, 0 is right over there. So I'm going to basically grab my big old long meter stick here, and I'm going to slap this line on here, being somewhat careful, because where they cross is going to be important to me. So now I'm going to go the other way. I'm going to go this side a little bit quicker. So I'm going to do my 0, 0 game here. If I let x equal 0, I get 75 for y. And if I let y equal 0, I get 50. So 0, 75, 50, 0. Connect the dots. All right, well now I got to figure out, I have four regions here. I got to figure out who's the shaded region. So if we go back to our original equations, since this is going to be a positive something y, this sign is going to hold true. It's going to be below the black line. So my shaded area is, and I'll kind of do this in green maybe, my shaded area is below the black line. So it's only one of those two bottom pieces. But then my other one is also less than. So I'm going to be below the red line. So it looks like my double shaded area is basically going to be this entire region right here. So everything in there, and I'm not going to bore you with my coloring skills, but everything in there is called the feasible region. So that is our FR, or our feasible region. Now, what's the most important about our feasible region is we need the vertices to it. So when we look at the vertices, we have 0, 45. We have 40, 15. And then we have right there 50, 0. Now, technically, we should also check 0, 0, but if we're trying to maximize absorption and we plant no trees of each, we're not going to have any absorption. All right, so that's that number. And then I move down. And now, this is where my objective equation, if you remember back from the notes, this is where we have an objective equation where we're trying to maximize or minimize something. And we're trying to maximize absorption. Well, we can make an equation for absorption. Spruce trees which is our x, absorbs 60 pounds per year. Or 600. So 600 pounds times every spruce tree. And then maple is 500. So maples don't do quite as good a job. And we don't have any other number because that's what the absorption is. And we're trying to see who's the biggest absorption rate. So here's where we're going to plug in our values. We're going to actually plug in, I'm going to grab my sheet because I've already done these. So I need to plug in all of these XY combinations. And we had 0, 45. We had 40, 15. And then we had 50, 0. Well, if I do plug in, 600 times 0 plus 500 times 45, that one came out to be 22,500 pounds per year. If I do the next one, 600 times 40 plus 500 times 15, that one came out to be 31,500 pounds. And then finally, if I do 50 in the front, 0 in the back, that'd be 30,000. So it's close. However, if you want to maximize the absorption, this is the combination that works. So we need 40 spruce and we need 15 maple. That's the best combination to satisfy all the constraints and the money and the square footage and get the most absorption. It's like we killed 3 birds with 1 stone. All right. Next, number 9, we moved into 3D stuff. So this is pretty cool. I like this stuff. So here's where we need to, this is isometric graph paper. Kind of helping you guys out because I thought it would be a little bit easier to do. So this is going to be our z-axis, positive z. This will be negative z. I think in class we set it up to where we went like this. This was the positive x. This was the positive y. Negative x, negative y. And the big thing is whenever you move counterclockwise, you got to go from positive x to positive y. So I can verify that. Like I set it up that when we move counterclockwise, we're going from positive x to positive y. There's like a hand-thumb rule in physics, but we won't worry about it right now. All right. So once we got a grid set up, now we got to find this location. We got to get to the right spot. So x, y, z. So in the x, we got to go 2 in the negative direction, which 2 in the negative direction is going to be 2 blocks this way. Stop right there. Then we got to go 4 blocks in the positive y. And then we got to go 5 blocks positive z. Right there. And that is the final destination. Right there is the point in 3D space. It's -2, it's +4, it's +5, and that dot is floating in 3D space in the right location. Next problem, number 10. So this one, I'm going to graph a plane, 3D plane here. And before I do that, what I want to do is I want to get the x-intercepts. So, not intercepts, intercepts. So x, I'm just going to put x int for short. So I'm going to get x, I'm going to get y, and I'm going to get z. And how you get those is you put zeros in for the other letters. So for the x-intercept, I cover that up. And x is going to be 1, because 12 times 1 is 12. And then for the y-intercept, cover up the x and the z, and you get -4. And then for the z, cover these two up, and you get 3. Now, once I get the intercepts, the x-intercept lives on the x-axis at positive 1. The y-intercept lives at negative 4. The z-intercept is at 3. And basically now, I connect these to make a triangle. Now, in real life, it's actually a plane in all directions, but how we represent it is we're representing it with this triangular plane because it's a little bit easier to see where it's crossing, how high it's going. So that is the plane and where it would cut through. All right, number 10 or 11. Big dog. So this one is solving a 3 by 3. So I need to, first goal is I need to turn this 3 by 3 into a 2 by 2. So I need to choose a letter to eliminate and get it down to a 2 by 2 and then solve the 2 by 2. So my goal is to solve a 2 by 2. And I'm going to write the 2 by 2 over here. Well, how do I know what letter to eliminate? I look through and I see, well, what's the easiest? You know, and the easiest thing to me right now is I have a pair of opposites right there. So what I'm going to do, I'm going to add these two rows together. All right, so I'm going to add those two rows together. I'm going to ignore the bottom row. And let's see what I get. When I add those two rows together, the x's disappear. And I'm going to get 6y minus 1z equals negative 14. So that was adding row 1 plus 2. All right, row 1 plus row 2. All right, well now I got to come up with a second one, but I got to get rid of x again. So I got to find a way to get rid of x by using two rows, but I can't use rows 1 and 2 again. So I'm looking at, well, maybe since I have a positive 2 and a negative 4, maybe I'll do rows 2 and 3. All right, so I think I'm going to use rows 2 and row 3. But I got to multiply row 2 by 2. Okay, and I'll show you what happens. When I multiply row 2 by 2, this row, I get 4x plus 2y minus 12z equals negative 12. And then my bottom row, I got negative 4x. I don't do anything to this one. Negative 16. Well, now when I add them up, I get to eliminate x again. So I have a negative 4y, negative 18z, negative 28. So that becomes my second equation over here in this 2 by 2 system. All right? I need that. This is key. You've got to get a new 2 by 2. This over here is really done now. Like I don't even need it anymore. I can get rid of it and I can ignore it. It could be on scratch paper. You're not important anymore. Now I got to solve this 2 by 2. So I'm looking at this 2 by 2 and I'm like, all right, how can I solve you? Who can I eliminate? Well, I could multiply the top row by negative 18 and I could get my z's to eliminate. I could multiply the top row by 4 and the bottom row by 6. I might want to do that. I kind of look at the bottom. Well, yeah, let's do that. I could do some dividing and shrink the bottom row a little bit, but who cares? I'm going to multiply by 4. I'm going to multiply by 6. And I'm going to get these y's to match up. So when I do that, I get 24y minus 4z equals negative 56. Then I got negative 24y minus 60 and 48 minus 108z. It's getting bigger than I like. And this is going to be negative 120 plus 48, negative 168. Hate dealing with bigger numbers like that. Add them up. Finally, I'm down to just z's. negative 112z. And that's going to be a negative 124. Divide. And holy smokes, I get z equals 2. Woo! Now, once you get that, it's like everything just starts to unlock. So now that I have z, I can go back up and I can plug this 2 into this 2 by 2 somewhere. So maybe I plug it in right there. So I'm going to get 6y minus 1 times 2 equals negative 14. So that's 6y minus 2, negative 14. Add 2, and divide. That gives me my second answer. Now I have 2 answers that I have to go back to my original 3 by 3. This ain't easy, man. I don't know if they're doing this in regular advanced algebra, but you're in honors, so we're doing it. So I go pick an equation, and I got to put my z in, and I got to put my y in. So maybe I pick, I don't know, maybe I'll pick this row right here. So negative 4x minus 6 times y minus 6 times z equals negative 16. All right, what do we get? That's negative 4x. That's plus 12 minus 12. Oh, man, we got lucky. Because plus 12 minus 12 just goes away. Divide both sides by negative 4. Sweet. I get x equals 4. So I finally have the answer. If you want to write that as an ordered pair, it's 4, comma, negative 2, not ordered pair, ordered triple. 4, negative 2, comma, 2. It's a lot of work. Problem's tough. All right, the old mixture problem. All mixture problems can be done similarly. So we have 2 different types of solutions. We have a 20%, we have a 70%. We need, so one key thing is we need 20 ounces. And we need that to be a 50% mix. So we need 20 ounces of a 50% mix. But all we have available in our lab is we have some 20%, some weak stuff, and then we have some strong stuff. Somehow we got to put it together. So the question is, how many ounces of each? So this is going to help me define my variable. So let's let x equal the 20% solution and y equal the strong stuff. All right? And we're basically mixing these together. You know, we have a certain amount of x, and we have a certain amount of y, and we know that's going to come out to be 20 ounces. But I don't know what x and y are. But now when I think about strengths, I need, the x is 20% alcohol. The y is 70% alcohol. And then the 20 over here is 50%. And just like I multiplied 0.20 times x, 0.70 times y, this 0.50 has got to get multiplied by the total amount, by x plus y, which was just 20. So these are pretty much my 2 equations that we need to solve. So we have a system of equations. I'm going to kind of go in and just get rid of the pictures. And we're going to solve this. What I could do is I could multiply this bottom row by 5, because that'll get my x's to match up. So I'm going to have x plus y equals 20. I'm going to have 5 times 0.20 is 1x. That's going to be 3.5y. And actually, I should have multiplied by negative 5, because I need my x's to be opposites, which is going to change this to a negative 3.5. And 50 times 20 is 10. 10 times negative 5 is negative 50. we can now combine. X's are gone. Positive 1, negative 3.5, that's negative 2.5y. Negative 30, divide. Get an answer of y equals 12. So I need 12 ounces, not 20. I need 12 ounces of the 70%. And if we needed 20 total, that means we need 8 ounces of the weaker stuff. So the correct answers were 8 and 12. Hopefully this helps you if you're getting ready for the retake. You can see what you did wrong on this one. See you.